I'm going to open up our drainage tiles now. Notice this one does not squirt out like the other one did. It's still running continuously through the tiles. Water moves in response to potential energy gradients and moves from the areas of higher potential energy near the top of this column to lower potential energy. And the lowest potential energy are these holes that are open to the atmosphere, the drainage tiles. The water will eventually run out of the column until it reaches an equilibrium at that point, where the potential energy inside the media, our sand, is the same as the potential energy outside. So the water table will resolve itself at the same level as those drainage tiles. The water moves more slowly through this very coarse sand than through the gravel, because this sand has smaller pores than the gravel. So the water flows more rapidly through larger pores than through smaller pores. Drainable porosity is that amount of the water that will move out of the soil under the influence of gravity when you start at saturation. So we had our column of coarse, very coarse sand. We raised the water table to 40 centimeters above this point where we put in a tile drainage system. We poked holes in it. And we can see that when we lowered the water table 40 centimeters, we collected 9.6 centimeters of water out of the column for a drainable porosity of 24%. We drained 9.6 centimeters of water out of the soil. We lowered the water table 40 centimeters.